So let's take a look at this functions and graphs question from the Leaving Cert Ordinary Level 2012 paper 1. It's question 5 and it's a question about the graphs of quadratic functions and linear functions. We're given the graph of function f, which looks to be a quadratic function, and then we're told that the graph of another function g is a straight line. We're told that the g of minus 1 is equal to minus 6 and that the g of 3 is equal to 6. Draw the graph of g on the diagram. So we've actually been given a good bit of information here. We're actually told two of the points that are on the straight line. They tell us that the g of minus 1 is equal to minus 6, which means that when minus 1 is inputted into the function, minus 6 is the output. And so we have a point for the curve minus 1, minus 6. So to place the points on the graph, we come over to 0, 0, we go back minus 1 on the x-axis, and then we go down 6 on the y-axis, and we place our point minus 1, minus 6. We also have another point on the graph. We're told that the g of 3 is equal to 6, which means when the input is 3, the output is 6. So the x value is equal to 3, and the output, the y value, is equal to 6. So to place this on our graph, we start at 0, 0. We move to the right 3 spaces on the x-axis, and we move up 6 spaces on the y-axis to this point here. Now we have 2 points on a straight line, and so we take a ruler and we draw a line through these 2 points. And that's the graph of g, or we can call it the g of x. The B part of the question asks us to use the graphs to find the two values of x for which g of x is equal to f of x. So we can see the 2 places on the graph where the curve and the line cross. And so reading those points, we have 0, minus 3 and 5, 12. Now the question asks us for the x value of those points. And so we have x is equal to 0 and x is equal to 5. So the C part says that the functions g and f are defined by g of x equal to ax plus b and f of x equal to x squared plus px plus q. So we have to use the information on the graph to try and find the values a and b in the linear function and p and q in the quadratic function. So to start with the linear function, we know that the point 0, minus 3 is a point on the straight line. So we're going to input 0 into the function and let the output be equal to minus 3. So this gives us that a times 0 plus b is equal to minus 3. Well, a times 0 is 0, so we have b is equal to minus 3. If we take the second point on the line, 5, 12, so we sub in for x equals to 5 and let the whole thing equal to 12. So a times 5 plus b is equal to 12. So a times 5 is 5a. We know that b is minus 3 from the earlier part, and this is equal to 12. So by adding 3 to both sides, we have that 5a is equal to 12 plus 3. So 5a is equal to 15. If we divide both sides by 5, we have a is equal to 3. And so the function can be rewritten as the g of x is equal to 3x minus 3. So coming over to the quadratic function and carrying out the same work, we're told that the f function crosses the axis at minus 1, 0 and 3, 0. And we can use these points to calculate the value of p and q. So taking minus 1, 0 and subbing in x equals to minus 1, we let the function equal 0. So minus 1 squared plus p times minus 1 plus q equals 0. Minus 1 squared is 1, minus p plus q equals 0. And subtracting 1 from both sides, we're left with minus p plus q equals minus 1. Taking the point 3, 0, we'll sub x equals to 3 into the function and let the whole thing equal to 0. So we have 3 squared plus p times 3 plus q equals 0, which is 9 plus 3p plus q equal to 0. And subtracting 9 from both sides, we get 3p plus q equals minus 9. So we can see that we're left with a simultaneous equation in p and q. We label the first equation a and the second equation b, and we'll try and solve the simultaneous equation. I'm going to multiply a by minus 1 to give me p minus q equals plus 1, and b is the equation 3p plus q equals minus 9. Summing the equations, I can see that minus q plus q is 0, so they cancel. P plus 3p is equal to 4p, and 1 minus 9 is equal to minus 8. If I divide both sides by 4, I get that p is equal to minus 2. Subbing p equal minus 2 back into either equation a or b will yield a value for q. So we'll sub it back into a, and we get minus p plus q equals minus 1. So p is minus 2, so it's minus 2 plus q equals minus 1. 2 plus q is equal to minus 1. And subtracting 2 from both sides, we get that q is equal to minus 3. And so rewriting the f function, we have that the f of x is equal to x squared minus 2x minus 3. So we found the values for a, b, p, and q, and the final part of the question asks us to use algebra to solve g of x equals to f of x. So we're going to let 3x minus 3 equal x squared minus 2x minus 3 and solve for x. So when they're asking us to use the algebra to solve g of x equals to f of x, they're asking us to confirm that these are the two coordinates of the points of intersection. So algebraically can we show that the curve f and the line g meet at the points 0, minus 3 and 5, 12. So algebraically can we show that the line g and the curve f meet where the x values are 0 and 5. So g of x is equal to f of x. G of x is 3x minus 3. So we let that equal to f of x, which is x squared minus 2x minus 3. We can see that if we simplify this, we'll get a quadratic equation. So collecting all the terms on the left hand side, we'll subtract an x squared for both sides. We have 3x minus 3. We'll add a 2x to both sides. We'll add a 3 to both sides, equals 0. Tidying this up, we get minus x squared. 3x and 2x is 5x. And minus 3 plus 3 is 0. We'll multiply across by minus 1 to give us x squared minus 5x equals 0. We'll factorize using a common factor of x. So x on x minus 5 is equal to 0. So we have x equals 0, or x minus 5 equals 0. And if x minus 5 equals 0, if we add 5 to both sides, we get x is equal to 5. So we've shown that the x values, where g of x equal f of x, are 0 and 5, as we showed in part B of the question using the graph. Note in this alternate solution here that we could have used the same 2 points, 0, minus 3 and 5, 12, that we used in the g function to solve for a and b, to solve for p and q in the f function. 0, minus 3 and 5, 12 are also points on f. And so in the previous slide we used minus 1, 3, but selecting any points on that curve, we'll find the same two values for p and q. A small reason why this method might be preferable is that 0, minus 3 has an x value of 0, which allows us to find q straight away. Q is equal to minus 3. When we sub in 5, 12 then, we can sub in this value of q and solve immediately for p equal to minus 2, saving us the work of having to solve a simultaneous equation.